Students, we are given this question, limit extending to 0 of a negative square root of a squared negative x squared divided by 4, the entire thing is divided by x to the power of 4, is given to have a limit. And it also states that a is greater than 0, and we expected to find the value of a. Now, to handle this question, we would be requiring binomial expansion. Okay, so when I say binomial expansion, I'm talking about the famous binomial series expansion. Two important series forms we will be requiring to answer questions of this nature. Now, the first one is 1 positive x raised to the power of n. I know you all know the binomial expansion. I'm not going to use the entire expansion. I'm only going to take finite terms in the series. It's always acceptable whenever we are dealing with series. So in this case, 1 positive x raised to the power of n, I'm taking it as 1 positive n times x. Now, why am I taking only first two terms? Because depending upon the limit, if x is going to be tending towards 0, the other terms are going to become very, very small. So there is no point in using them. So that is the rationale that is being used to take only finite terms. Now, in this case, I'm taking two terms. Now, there is also another expansion, 1 positive x raised to the power of n. In this case, we will take three terms, say 1 positive n times x, positive n into n negative 1 divided by 2 times x raised to the power of 2. So, these two forms would be predominantly used. As I mentioned to you, we are not taking other terms owing to the fact that x is tending towards 0. As x approaches 0, the other terms would become very, very small. So there is no point in taking them on. So having mentioned this, I'm going to be solving this question. So foremost, as always, we will have to apply the limits. So when I apply the limits, I'm getting 0 by 0 form. So you can clearly see this is 0, this is a squared, root of a squared is a negative a is 0, this is going to be 0, this is going to be 0. So 0 by 0 form. So that is also a rationale for us to conclude, because definitely it has to lead to 0 by 0 form, because it says that the function has a limit. So now that we have got 0 by 0 form, we have the liberty of choosing the method that we want to apply onto this function so that we can extract the limit. So we would be using binomial expansion. So for that, to make this applicable or to facilitate the application of binomial expansion, I need to do some initial manipulation. So what am I going to do? I'm going to just start off by stating that limit extending to 0, and I'm going to rewrite a squared negative x squared as a squared negative x squared raised to the power of 1 over 2, followed by x raised to the power of 2 divided by 4. The entire quantity is divided by x to the power of 4. I'm not going to be much bothered about the limit that is given. First, let me simplify the terms that are present here. Now, as you can clearly see, the binomial expansion starts with the term 1. So I need to get the term 1 there. So this is rewritten as a negative. If I were to take a squared out, this is going to be 1 negative x squared divided by a squared. This is raised to the power of 1 over 2. This also has to be raised to the power of 1 over 2. Followed by negative x to the power of 4 divided by 4. Negative x to the power of 2 divided by 4. The entire term is divided by x to the power of 4, and we got the limit x tending to 0. So this is what we have got. Now clearly this can be rewritten as limit x tending to 0 of a negative. Now a squared raised to the power of 1 over 2, that would give me a, followed by 1 negative x to the power of 2 divided by a squared. This is raised to the power of 1 over 2 negative x to the power of 2 divided by 4. This entire term is divided by x to the power of 4. Okay, now having got this, I'm going to apply binomial expansion to this particular term. So for that, let me just use this space here. So I'm going to consider 1 negative x over a raised to the power of 2. This is raised to the power of 1 over 2. Now we know that 1 positive I'm going to use this expansion. In fact, I will be using this. 1 positive x raised to the power of n is equal to 1 positive n times x positive n into n negative 1 divided by 2 times x to the power of 2. So in this case, instead of plus, I got a minus. So that means the signs would be alternating. That is the first observation you will have to take into consideration. The second one is, in place of n, I got 1 over 2. And in place of x, I've got x over a raised to the power of 2. So that is the second observation. So having stated that, let me expand this. So this is going to be equal to 1. The first term would have an alternating sign. So that means that term is going to have a negative sign. And my n is 1 over 2. So place that 1 over 2 there. Let it be in parenthesis. Times x. My x is x over a raised to the power of 2. Right. So let me write it as x squared and a squared. So the best way to do is to place them as a single term. In fact, instead of actually placing a parenthesis, you could have taken the 2 inside, but I don't want to make some alteration now. So let me continue. So followed by, I already taken a negative sign, so this is going to be positive. Now in place of n, I need to use 1 over 2. So this is going to be 1 over 2 times 1 over 2 negative 1. Of course there is a 2 there. X squared is going to be x squared a squared raised to the power of 2. Okay, so I'm going to stop with this term. Now I can rewrite this as 1 negative 1 over 2 times x squared divided by a squared positive 1 over 2 times 1 over 2 negative 1. That's going to be negative 1 over 2. Already there's a 2 there. So that can be brought over here. And then you got x to the power of 4 divided by a to the power of 4. So this is what we have got. Now, is there any simplification that is possible? Well, let me just rewrite this again. So it's going to be 1 negative x squared a squared times 2, and this is 2 and 2 and 2. So you got a lot of 2's there. So that's going to be negative 1 over 2 times 2 is 4, 4 times 2 is 8, and this is going to be x to the power of 4 divided by a to the power of 4. So this is the expansion. This is this term that we would use instead of this term. So let me place it there. So if I were to take this as 2, therefore my 2 can be rewritten as limit x tending to 0 of a negative a times 1 negative x squared over 2 times a squared negative 1 over 8 x to the power of 4 a to the power of 4. That is for this term, followed by negative, there is x squared over 4. Okay, so divided by x to the power of 4. So now you need to make some further simplification. So this is equal to limit x tending to 0 of a negative a. Now this a is coming in, so it's going to be positive x squared over a and a squared, they get cancelled, leaving me 1a, followed by negative negative positive x to the power of 4 8 a to the power of 4 with a there, that's going to be a to the power of 3, followed by negative x to the power of 2. I mean, that has to be divided by 4. So this is what we got. Positive a, negative a gets cancelled. So now I got x squared over 2a and x squared over 4. So we can club these two things together. Of course, there is a x to the power of 4 term there. So let me just place that x to the power of 4 term there. Now if I were to club these two things, I can take x squared out and I can rewrite this as 1 over 2a negative 1 over 4 positive x to the power of 4 divided by 8 times a to the power of 3 divided by x to the power of 4. This entire thing will have a limit x tending to 0. Okay, now let me give you the solution here. Now I got x to the power of 4. Now I'm going to use this part for your understanding. Now, by algebraic law, if I got A positive B over C, I can rewrite it as A over C positive B over C. Okay, so I'm going to write this as x to the power of 2 times 1 over 2a negative 1 over 4 divided by x to the power of 4 positive x to the power of 4 divided by 8a to the power of 3. Now x to the power of 4 I can actually write it over here, x to the power of 4. Okay, now this is limit x is tending to 0. Okay, let me place that. Now clearly an x and x squared and x can be cancelled, giving me 1 over 2a negative 1 over 4 times 1 over x to the power of 2. You have a limit x tending to 0, and this is followed by x power 4 can be cancelled, giving me 1 over 8 times a raised to the power of 3. Okay, now please follow me. As x tending to 0, 1 over x will tend to infinity. Now if 1 over x tends to infinity, this is infinity plus something, which means I am getting an infinity. But the question says the function has a limit L. So in other words, the function is already set to have a limit L, and we are now getting the limiting value for the function to be as infinity, which is actually a contradiction. So to avoid that contradiction, what should we do? We have to make sure that this term is 0. We have to make sure this term vanishes. So when would this term vanish? This term will only vanish when a is equal to 2. So if a is equal to 2, this is going to be 1 over 4 minus 1 over 4. This will become 0. This entire term will, in fact, this entire term will generate 1 over 8 times a raised to the power of 3. So it wouldn't be infinity. So I hope you are able to catch what I'm trying to say. So I'm going to state that this is for your explanation. This part which I've done is for explanation. You don't have to include that in the solution. So I'm going to write it here. Since given the function, okay, as the limit L, this implies x squared term should vanish. This means a should be equal to 2, right? They should perish. So for that to happen, a should be equal to 2. Hence, this in turn would imply limit x tending to 0 of x squared of 1 over 2a negative 1 over 4 positive x to the power of 4 divided by 8 times a to the power of 3 divided by x to the power of 4. This is giving us 1 over 8 times a to the power of 3. Now a is equal to 2. So this means 8 times 2 raised to the power of 3. 2 raised to the power of 3 is 8. 8 times 8 is 64. So the value is 64. So therefore L is equal to 64, which is a good place for us to stop. Thank you, students. I hope you understood this entire question.